Hello, my students. We are entering chapter 8. We are going to be talking about rational exponents, but mainly we're focusing on radicals in this chapter. In today's lesson and the next couple of lessons, we are really hitting radicals hard and talking about different ways to write different types of exponents. And then probably after Thanksgiving, honestly, at this rate, after Thanksgiving, we'll start talking again about complex numbers. And by again, I mean, we really haven't talked about them tons in this section. Maybe you got a little hint of this in a previous class, but we will dive into complex numbers after Thanksgiving. All right, so section 8.1, all about radicals and radical functions. At any point in this video, please feel free to stop and make sure that your notes are where you want them to be. Yeah, cool, let's go. All right, so to find the square root of a number, you guys know how to find some square roots at this point. If the number is a, then I want to find a number that was squared to get a. So for instance, if I have, 8 squared equals 64 and negative 8 squared equals 64, well then the square root of 64 could either be 8 or negative 8, right? So both 8 and negative 8 are square roots of 64. We denote the non-negative, or sometimes we call it the principal square root with the radical sign. You guys are used to this radical sign right there. You've seen that before. And then we denote the negative, not the principal one. We denote the negative one with a little negative sign out in front, right? So even though if I were to, say officially the square root of 64 could be 8 or negative 8, we tend to try to specify as much as possible. If you just see the radical sign just by itself, that typically is just the principal, the non-negative, the positive one, and we'll try to, denote when we want it to be the negative one, the negative 8. All right, so in a radical expression, this value that is underneath the radical sign is called the radicand. And again, here, principal and negative square roots. If a is a non-negative number, then the square root of a is the principal or non-negative root, and then we'll try to denote with a little negative if I am specifically asking for the negative square root. So radical sign, radicand, principal roots, those are some of your buzzwords for today. From here on out, for the most part at least, we get to do some problems. We will have another page or two like this, like another note page or two, a few. But let's get into some actual math here. All right, 8 problems. We're starting off fresh. So assume that all variables represent positive numbers. So for instance, a, because I just see the square root sign, square root of 49, what is that, y'all? You know it, 7. So 7 squared is going to be 49. If I'm asking for b, square root of 0, guesses as to what that would be? Yeah, it would just be 0. So it's not like undefined or anything like that. Square root of 0 is 0. What if you guys have a fraction? Well, square root of 25 over 16, you can honestly think about that. And we'll talk more in detail about this later on today and tomorrow. You can kind of think about splitting those two up. What's the square root of 25? Well, 5. What's the square root of 16? Well, 4. So the square root of 25 over 16 is 5 over 4. What about this one? This is interesting with the decimal place. I shouldn't have scrolled too far. The square root of 0.36. Is there any number that when multiplied by itself gives 0.36? Maybe you can play around with your calculator a little bit, but maybe you won't be allowed a calculator for every check-in and quiz for this section. We'll see. For this one, 0.6, right? If I were to multiply 0.6 times 0.6, I would get, 36. 6 times 6 is 36. But then because this first one, I have 1 decimal place. The second one, I have 1 decimal place. My final answer, I would boop, boop over 2 decimal places. So I'd have 0.36. So 0.6 is the square root of 0.36. All right, what about this one? Square root of x to the 8th. So what x with an exponent times itself would give us x to the 8th? Remember, when I am multiplying, like x to the little question mark times x to the little question mark, when I'm multiplying with the same base, I want to add those two. So what plus itself equals 8? X to the 4th. Down here, I have square root of 16x to the 14. So square root of 16, that's just going to be 4. If you're dealing with square root of x to the 14th, basically what we want to do here is similar to what we did for e. What number would work as an exponent so that when I add it to itself, it gives me 14. That's going to be 7. So 4x to the 7th. And we're going to learn some tips and tricks in another day or two with some ways to kind of rethink some of these and rewrite some of these. That'll be even more helpful. All right, g. Guys, what's g? Okay, cool. -2. What about the square root of -4? So some of you might be saying something about, oh, is there an I in there? I know that you guys have seen those before, maybe. We are not going to be talking about I right now. We want to be focusing on real numbers for this lesson and where we're going with this lesson. So for this one, if you had this on a test right now, we would just say is not a real number. I have no number that when multiplied by itself equals a -4. Okay, so this would not be a real number. Officially, it is an imaginary number, but again, we're not going to be focusing on imaginaries too much right now. All right, square roots of perfect square radicands simplify to just rational numbers. Guys, remember all the way back in the beginning of this class when we talked about rational and irrational numbers? Like rationals can always be written as some type of fraction. A lot of the numbers that, like, 3, 47, blah, 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 I could write that as 3 over 1, 47 over 1. So it can be written as a fraction. Numbers that can be written as a quotient, right, of integers. But then square roots of numbers that are not perfect squares, like 7 or 10, those would end up being irrational numbers. Try to think back, what do we mean by irrational numbers? Well, one of our explanations, one of our definitions was a number that just keeps going on and on and on forever and ever. It's never going to really stop. We had a couple definitions for irrational, but that's one of them. Sometimes, so if requested, you can find a decimal approximation for these rational numbers, but you will never, like if I have the square root of 7, you will never be able to tell me like that is this exact number. It is going to be irrational. It's going to keep on going forever and ever. All right. Okay, what about cube roots? We've heard about square roots. Let's get into cube roots. The cube root of a real number is written with a little 3 outside. So if you don't see any number, we're assuming it's a little, secret 2 out there. It's asking for the square root. Anything greater than 2, you should see the number on the radical sign. So the cube root of a equals b if and only if b to the 3rd power equals a. So let's try some examples of that one. Just refamiliarize ourselves with this a little bit. So here I want to find the cube root. So what number times itself, so, x times x times x equals 27. Maybe you guys can think it through here. I'm looking for 3. Another way to think about cube roots would be, okay, if I have the cube root of 27, let's just start factoring this bad boy. This would factor into 3 and 9. 9 would factor into 3 and 3. If I have a number that's showing up 3 times, I can pull that outside of the radical sign, right? So 3 times 3 times 3, well, then the cube root of 27 is just going to be 3. We'll be able to simplify some other problems like this too. Again, we're going to be doing lots of these problems. You'll get lots and lots of practice. With cube roots, now I'm looking at B. With cube roots, I am allowed to have a negative underneath my radical sign. I can have a negative in the radicand, all right? Because if a cube root is something times itself, x times x times x equals -64. Well, if x is negative, then this would work out, right? A negative times a negative would give me a positive, and then that positive product times a negative would give me a negative. So can you guys figure out what number this would be for this one? Another way to think about it would be, okay, if I have the cube root of -64, well, let me just focus on 64 for a second. That could factor into a couple different things, but 4 times 16, and then 16 could factor into 4 times 4. And yes, you could keep going. You could break each of those 4s down into factors of 2, but I see 3 4s here. And I just need to make sure, because it's a negative radicand, my answer is -4. All right. Anytime that you are taking the cube root of a fraction with perfect squares, so cube root of 27, we just said was 3. Cube root of 64, 4. Boom, 3 over 4. All right, what about this last one? Cube root of -8x to the 6th power. Let's first think about that cube root of -8. What number times itself equals -8? Well, I know it's going to have to be negative. We're looking for -2 right there. -2 times -2 is 4. 4 times -2 is -8. And then with this x to the 6th, how can I separate that as x to the something times x to the something times x to the something equals x to the 6th? Well, I know if I'm multiplying everything with the same base, I would need to add these. So another way to think about that is 3 times what number equals 6, 2. So we're looking at -2x squared. Those would be our cube roots over there. All right, you can continue to find other roots as well using this similar root. So to find the nth root, n just represents, any number basically, any number here. Sometimes we call it the index n. I could find the 7th root of something. I could find the 49th root of something if and only if b raised to that power equals your radicand, equals a. So if the index n is even, then the root is not a real number when a is negative, right? So only when it's even. So if you're taking the square root, if you're finding the 4th root, the 6th root, if your radicand is negative, you're not going to have a real number there. But if the index, if that n value is odd, so finding the 7th root of something, finding the cube root of something, finding the 9th root, then that root will be a real number, right? Because if I multiply a negative an odd amount of times, my answer is odd. If I multiply a negative an even amount of times, it's always going to be positive. Like it is impossible to have, let me think, -7 times -7. That's always going to be 49, right? A negative times a negative is always positive. So I cannot possibly figure out the square root of -49. Okay, that's not going to be real. Folks, you're doing great. We're going to keep going with this. Simplify more. Okay, let's see what we can do with these. The 4th root of 256. So again, another way to think about finding the 4th root, you can just try to visualize this. What number times itself, x times x times x times x equals 256. You can just try to hardcore this, or I would just start splitting 256 into some factor pairs. So let's see here. 256 could be split into 4 and 64. 64 could be split into 4 and 16. 16 could be split into 4 and 4. Oh, look, I see 4 times, and I have factored this as much as I can, so the 4th root of 256 must be 4. Maybe you guys remember this from previous math classes, right, with just a square root of 16. If I can split that up into, a pair of numbers, beautiful. Then that just simply is 4. If you have any factors left, then they would stay underneath the radical sign. Same thing would apply to these larger roots. Okay, what about the 5th root of -32? So again, because it's negative, I know that my answer here is going to have to be negative. So let's try to split this up into some factor pairs. And I'm just going to focus on the 32 here. All right, we already said that it's going to be negative, but I'm just going to focus on my factor pairs for positive 32 for this moment. All right, so 32 can be split into 2 and 16. 16 can be split into 2 and 8. 8 can be split into 2 and 4. 4 can be split into 2 and 2. Wow, 2. I have 5 2s. So -2 must be our answer here, all right? Whatever number is outside of your radical sign, you are looking for that number to show up that many times, and then you can kind of pull it out from under that radical sign in a way. Oh, this is just a fun little one to throw in here. Root 36, what would that be? Hopefully you said -6, right? Square root of 36, 6 times 6 equals 36, and then they specially said for the negative one here. Okay, what about this last one? This is kind of similar to a problem that did we just do this problem? Guys, we just did this problem. This is the same exact problem as up there. Okay, cube root of -8, -2. Cube root of x to the 6th, x squared. That one was a nice one for us. But again, here, you could split these into factor pairs. You could say, hey, 8 would be 2 and 4. 4 would be 2 and 2. Okay, 2 is showing up 3 times. So I can pull a 2 out of there. Because it was a negative 8, I want to make sure it's a negative 2. And then 6, you could split up into, you know, x squared times x to the fourth. X to the fourth is the same as x squared times x squared. Oh, look, x squared showed up 3 times. That is going to be able to have the cube root taken evenly because I see it's showing up 3 times, the same number as the root. Wow, let's keep going. Oh no. Okay, let's keep going. If you have the nth root of something raised to the n power, you can kind of think of those two things undoing each other, right? Raising something to an exponent and taking a root of something, those are basically inverse operations. So if they're the same number, they're kind of undoing each other. If it is an even positive integer, then you're always going to have the absolute value of this. So think about this like this. If I have negative 2 to the third power, what would that be? That would be 8, okay? If I have the cube root of negative 2 cubed, well, negative 2 cubed is 8. What is the cube root of 8? It's just going to be 2. Okay, so that's what they're saying over here. Even if I start out with a negative, the answer is going to be the absolute value of whatever that a value was. So the absolute value of negative 2 is still just 2 because n is an even positive integer. And anything raised to an even positive integer is going to end up being even. But if it's an odd positive integer, then it would just be a. Whatever this is, it is just that. So it could be positive or it could be negative. All right. Again, feel free to stop, jot things in your notes if you need to. We have a bunch of examples on the next slide. This section, because they're not really crazy long problems, we're just doing them. We're just kind of doing math drills here. All right, let's get into it. So here I have the square root. Again, think about a little hidden 2 out here. So I have a 2 and a 2. What was that rule? It's going to be the absolute value of whatever a was. The absolute value of negative 4 is just 4. That's our answer. Over here, okay, so this one, x to the fourth. So it seems like these numbers don't match right now. 2, 4. In my world, that does not match. But let me erase a little bit here. I can rewrite x to the fourth as the square root of x squared squared. Now those numbers match. It's an even n value, so it's the absolute value of x squared, which is just going to be x squared. For these problems, though, we will leave the absolute value bar. So absolute value of x squared, we can just leave that alone because I have an x in there, right? If I didn't have an x, then I would want to, then you could do what we did up here, right? The absolute value of negative 4 is just 4. But because I have a variable in there, I will just leave those bars alone. That is the way to simplify that expression. Okay, feel free to zoom ahead of me and then scooch ahead to see if you got the same answers. So down here, the n value is even, so I'm looking at the absolute value of a, the absolute value of x minus 3, whatever is inside this expression here. Okay, down here, it's odd. What was different about that? If you need to go back a couple of seconds and check, feel free. Our a value is negative 8. If it's odd, that just stays as whatever it is, so negative 8. Again, you can always kind of check yourself too. What's negative 8 to the third power? You could figure that out. And then what's the cube root of that? It's still going to be negative. Over here, I have 7 and 7. That's odd. So that rule is, hey, whatever you see inside of here, that's your answer. 3x minus 5. Boom. Done. Okay, for this one, square root of 49, well, that's just going to be 7. And then the square root of x squared, that would be absolute value of x. So officially, you could start thinking this one as absolute value of 7x, but absolute value of 7 is always going to be 7. So I can write this as 7 and then the absolute value of x. Okay. And again, think about 49. That's the same thing as 7 squared. So officially, 49x squared is the same as 7x squared. That's why I said absolute value of 7x. Okay, g looks a little different. How could I rewrite g to be something squared? Maybe this one is looking familiar, maybe not. Either way, that's okay. If I had x plus 2 times x plus 2, and you can check this on your own, FOIL this bet out, x squared plus 2x plus 2x plus 4. That would get me x squared plus 4x plus 4. I can rewrite this whole thing as the square root of x plus 2 squared. And you guys had a formula like that a week or two ago. Because I have an even n value here, an even index, 2 and 2, my answer here is going to just be the absolute value of a, and a in this case was x plus 2. Alrighty. We're gonna keep chugging along here, folks. You're doing great. Actually, I have no idea how you're doing because I'm not there, but hopefully you're doing well. Okay, here they are asking us for function values. So a little bit of a change of pace for us here. They're giving us f of x, they're giving us g of x. I wish I could be asking you guys this in person, but someone remind me, what do I do if I see f of some number? Like what do I do with this 9? Hopefully you're saying I'm going to plug in 9 everywhere I see x. So f of 9 would equal the square root of 9 minus 5. Square root of 9 minus 5, well, that would be the square root of 4. Square root of 4, that's going to be 2. So that's your answer for A. Feel free to go ahead and try the rest of these ones, see how far you get, see if we get the same thing. I'm going to keep plugging along. F of 11, I'm plugging in 11 for x. 11 minus 5 gives us 6. I can't actually simplify that anymore. If I factored 6, it would just be 2 and 3, so I'm not seeing any factors show up twice, so that's as simplified as that's going to get, square root of 6. G of negative 2, okay, G of negative 2. Now I'm dealing with this function over here. Cube root of negative 2 plus 3, that's going to be the cube root of positive 1. Well, 1 times 1 times 1 is 1. That's my answer. G of 3, cube root of 3 plus 3. 3 plus 3 is 6. Can I simplify that? No. All right, so that is our final answer over there. Again, quick way to check. Start factoring your radicand. 6 factors into 2 and 3. I'm not seeing any number show up 3 times, so I cannot simplify by changing it into anything else. Okay, that's as far as I can go here. All right, to end this lesson, folks, we're going to do a tiny bit of graphing, and we're just doing like good old plot some points graphing. All right, so I have example 6 and example 7. We are graphing the square root function, and then we are graphing the cube root function. These are parent functions, so the square root function, just the square root, that's going to kind of be our basis function. I could be adding, subtracting things just to x to the whole function, and that would change and shift and stretch and yada, 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 this whole function. But this is your parent function. This is where you're going to start for all square root graphs, okay? We're not going to do tons of graphing in this section, at least not this week, but we're just going to do a little bit with this graph. So first we want to identify the domain. What values could I not have, or let me rephrase this, what values would not give real numbers, okay? I can't have negatives. So my domain is going to be all non-negative numbers. Another way to say that would be x is greater than or equal to 0. Another way to say that would be including 0 all the way up to positive infinity. Okay, so 3 different ways to state the same thing. Those are all my domain. Positive numbers here and 0. Then what we want to do is we want to evaluate the function for several values of x. We're going to be creating a t-chart here, an xy table. I'm going to plot those points, then we're going to connect those points. So take a second to create a little xy axis for yourself, a nice little coordinate plane. We are going to create a little t-chart over here with some x values and some y values. I don't want to choose any negative x values because I know for a fact those are not going to be on my chart, but we did say we could start with 0, so let's start with 0. Okay, if I plug in 0 for x into this function, what would y equal? 0. If I plug in 1, what would y equal? 1. Okay, I'm going to start plotting those 2 points. So I have this point 0, comma 0. I have this point 1, comma 1. What if I plugged in 2? I would just get the square root of 2. If you plug that into your calculators, that would give you roughly something around 1.4. So on our graph, I know that x equals 2 is over here, and then y equals a little more than 1. That's going to be somewhere around there, okay? But I do want to keep things exact, so I'm going to label my point as 2 radical 2. I'm going to plug in, I think, 4 and 6, and then we'll call it quits. We just want a few more points so I get a nice idea of where the graph is going. So I'm going to plug in 4, I'm going to plug in 6. Square root of 4, that's going to give us 2. Okay, so that's this nice point right up here. And then if you plug in 6, what would that give us? Okay, square root of 6. Again, feel free to kind of plug this into your calculator and see, hey, am I getting, you know, some kind of decimal that's actually going to be a little bit more helpful for us. You know it's going to have to be greater than 2. It's going to have to be less than 3. So it's going to give you something around here. And then we can connect this up with a nice smooth curve. And that right there is your parent function of the square root function. All right, so you might see other functions that have a square root in them. They're all going to be related to this parent function in some way, but just maybe shifted, stretched, yada, yada, yada. Okay, final problem for this video is we are going to graph our cube root function and see, is it similar to our square root function? Is it a little different? What's going on here? For our domain, oh, I'm realizing that's so funny. Okay, haha, you saw this domain the whole time. Whoops. Okay, identify the domain. I'm just telling you straight up, all real numbers. But hopefully this makes sense, right? Because when we were thinking about odd roots, I'm totally allowed to have negative numbers in there, okay? So my graph doesn't have just like a starting place. It can go all the way to negative infinity, all the way up to positive infinity. So my domain is all real numbers. You can write that in words. You can write that like that. You can write that like this. Lots of different ways to put that, okay? All reals. Then we're going to do the same thing. We're going to create a t-chart. Again, please feel free to pause and, you know, create a little XY axis. Do what you got to do here. So we're going to do a similar thing, pick some values for X and for Y. I do want to pick some negative values this time. So I am going to actually start in the negatives. I'm going to start all the way at, I'm going to do -8, okay? Why am I doing -8? Well, because I know it's a perfect cube, right? So I want to pick some easy numbers for me. We'll have to do some that won't simplify beautifully, but we'll pick some easy numbers. So I'm going to do -8. I'm going to do -4. -1 is another perfect cube. That'll be easy for us. 0, 1, 4. I'm just kind of mirroring these numbers here. Okay. So what is the cube root of -8? Hopefully you're saying -2. Let's plot that point. So I know this is -1, -2, -3, -4, 5, 6, 7. So -8 is actually all the way out here. That's kind of off our graph, and then -2 would be down here. So I have this point over here, -8, comma, -2. What's the cube root of -4? Well, the cube root of -4 is kind of just the cube root of -4. You are allowed to rewrite it as the negative cube root of 4. Those two things both mean the same exact thing, right? Because if I'm finding the cube root of a negative, it is going to be a negative number. If I find the cube root of a positive number, it's going to be positive. So this is just saying the negative of the positive. How many times can I say those words? Negative cube root of 4. Okay. Again, don't totally know what that, there's no exact number there. But I know that that's going to have to be somewhere between 1 and 2. So I'm at here, -4 over here. And I know this is going to be this point somewhere between 1 and 2 over there. All right, what is the cube root of -1? Hopefully you said -1. What's the cube root of 0? 0. Cube root of 1? 1. And these are just going to mirror it. Cube root of 4 and then +2. So let's go ahead and plot the rest of those points. So -1, -1 is this point right here. -1, -1, 0, 0 is right here. 1, 1, 4, somewhere between. And then 8 is all the way off here, and 2. So 8, 2, 4, cube root of 4. And then over here we had -4, negative cube root of 4. All right, we want to connect these up with a smooth curve. It's going to look something kind of like this. That'll go off for eternity. this one kind of swoops down over here. That'll go off for eternity. And this is your parent function for everything that has a cube root as its highest term in it. Folks, with that, congrats, you're done with this lesson.